This is one of a series of videos exploring the different patterns of chemical reactivity that we observe. This particular video is about reduction-oxidation reactions, which is often abbreviated redox reactions. In order to comprehend this topic, you'll want to be familiar with how to write out and balance a chemical reaction, identifying ionic compounds, and be able to determine the charges on ions pretty comfortably. Reduction and oxidation, there's some handy mnemonics to remember who gets reduced and who gets oxidized. But the general idea is that electrons get moved. So somebody's losing the electrons and somebody's gaining the electrons. And Leo goes grr is my personal favorite. There's also oil rig if you want to remember that one. But basically, if you lose electrons, you're oxidized. That's the Leo. And if you gain electrons, well, let's make this a different color. That would be pretty. If you gain electrons, you're reduced. It turns out that if you lose electrons and you're oxidized, you're also the thing that's helping reduction happen, because you're losing the electrons that somebody can else pick up to be reduced. So if for maximum confusion, and I don't know why they did this, if you're oxidized, you are also considered to be the reducing agent. And if you are reduced, if you're the item that is, or the substance that's gaining electrons, then you are the oxidizing agent as well. Oxidation and reduction always come together, so you can't have one without the other. If somebody's losing electrons, somebody else is picking them up. If somebody's picking up electrons, somebody had to lose them. So if you're working through a reaction and you only see reduction happening, you want to go back, or just oxidation happening, you want to go back and check your work, because you should always see the two occurring together. There are a number of rules for oxidation numbers. At this introductory level, we are just going to focus on a few of them because most of you don't really need to know oxidation numbers beyond being able to identify whether something's reduced and oxidized. And you'll notice that these pieces of information that I'm going to give you about oxidation numbers are things that we already kind of know. So for instance, you know that when an element is alone and it has no charge, its charge is 0. Well, guess what? Its oxidation number is also 0. If you have an ion, let's say you have a sodium ion, Na+1, then the charge on the ion is equal to the oxidation number of the ion. Hey, great, we already know how to do that as well. And then finally, the charge of the ion in a compound is the oxidation number of that substance in a compound. So if we were looking at sodium chloride, we know from the periodic table that sodium is existing as a +1 ion in that compound, and chlorine is existing as a -1 ion. And so now we also know that sodium has a +1 oxidation number and chlorine has a -1 oxidation number. There is some convention for how to write oxidation numbers. I'll generally ignore it in this video. So if you're looking for more information about that, you'll have to look somewhere else, because I'm just not that concerned about it. So let's look at an example. When a metal forms an ion, is the metal reduced or is it oxidized? And then what about a nonmetal? So if you think about a metal, for instance, let's take calcium. When it forms an ion, it becomes calcium with a +2 charge. And when it did that, we know from our discussion of the periodic table and how things form ions that calcium lost 2 electrons. Because calcium lost 2 electrons, they show up on the product side here. So this is actually true of all metals. So all metals lose electrons when they form ions. And so that means that all metals, when they form ions, are oxidized. Let me write this a little bit more clearly. All metals are oxidized when they form ions. On the reverse side, we have something like, well, let's take sulfur. Sulfur, we know, wants to gain electrons, and it will form a negative ion, so it will actually pick up 2 electrons and add them to its neutral self, forming the S-2 ion. So what we see here is that nonmetals gain electrons to form ions, and they are reduced. Because we're remembering Leo, lose electrons, oxidize, goes, gain electrons, you're reduced. So in general, metals, when they form ions, will be oxidized, and nonmetals, when they form ions, will be reduced. Let's look at a couple of reactions. Can these reactions that I've listed here be classified as redox reactions? Is there reduction and oxidation taking place? And in order to answer that question, what we really want to know is, do charges change? So does the charge on a particular element in the reactants change between the reactants and the products? That's what we're looking for. Because if that occurs, then we know that electrons are being lost and gained, and that means reduction and oxidation are taking place. If the charges stay the same, then we don't have reduction and oxidation, and it's not a redox reaction. So going back to our general rules for oxidation numbers, we know that elements by themselves have no charge and thus have an oxidation number of 0. So when I look at this aluminum here in this first reaction, it's all by itself, I know that its oxidation number is 0. Chlorine, the other reactant, also all by itself, has an oxidation number of 0. When I look at my products, now I have some charged species because aluminum and chlorine are forming an ionic compound. And aluminum, we know, given the context of this formula, forms a +3 ion, and so we know it also has a +3 oxidation number. Chlorine forms a -1 ion, and so we talk about it as having a -1 oxidation number. And what I notice more importantly here is that aluminum started at 0, but now it's +3. So aluminum went from a 0 to a +3. And what we see happening there is that aluminum lost electrons. That means aluminum was oxidized. Now, if I've done this correctly, that means that chlorine must also have something going on. And we look at chlorine, we see that 0 oxidation state has now become a -1. So chlorine has gained electrons and therefore was reduced. So Cl2 is reduced in this reaction. And so indeed, this reaction is a redox reaction. Check. Yes. Let's look at the next reaction. I start with sodium hydroxide. This is my basic ionic compound that I can tell the charges of. I know that sodium is +1. The hydroxide is polyatomic ion with a -1 charge. Potassium in K2S has a +1. Sulfur has a -2. When I go over to my product side, I see sodium still has a +1. Sulfur still has a -2. Potassium still has a +1. And hydroxide is still a -1 polyatomic ion. I don't see any difference in my charges between my reactants and what I started with and my products. And so that tells me that nobody lost any electrons and nobody gained any electrons, and so this is not a redox reaction. Let's look at determining which substance is reduced and oxidized and what's the oxidizing agent and the reducing agent. Keeping in the back of our mind, Leo goes Gur. We lose electrons, we are oxidized. We gain electrons and are reduced. I'm also remembering that the oxidizing agent is going to be the thing that's reduced, and the reducing agent is going to be the thing that's oxidized. So really, if I can figure out the first two, if I can figure out A and B, then I've got C and D without too much of a problem. To do this, I want to check charges. I see that zinc is an element by itself, has a charge of 0 and an oxidation number of 0. CuCl2, there's a transition metal in there, so I'm going to start with my chlorine. See, that's a -1, which means the copper must be a +2. If you don't remember or you're not sure how I came up with that +2 charge, you'll want to go back and review transition metal ionic compounds, because there's a video that talks about how to determine that charge here. When I look at the products, I see copper is all by itself. It's at a 0. Chlorine is still a -1. And zinc is now a +2. So I see that zinc started with 0 and went to +2. And copper started with +2 and went to 0. So let's look at zinc first. I start with 0 and I become more positive, which tells me I'm losing electrons. That tells me that zinc is oxidized. And since it's the thing that's oxidized, it is also the reducing agent. Copper, on the other hand, goes from +2 to 0. I'm adding electrons, right? I have to add 2 electrons, 2 negatives to +2 to get 0. So Cu +2 is reduced. And it is also the oxidizing agent.